So today we're going to cover section 6. Now the title says inequalities in two triangles and indirect proof. We will not be covering the indirect proof. We're going to skip the slides of what's posted on Canvas. I've shortened mine. My presentation here that I'm videoing is only 6 slides long. So all you're going to be responsible here is the Hinge theorem and its converse. So the next slide actually lists what the Hinge theorem states. So it's Theorem 5.13, and it does have a name, and it's called the Hinge theorem. And this is what I mean about all these crazy words. And this is why I'm going to demonstrate what the Hinge theorem is with my scissors momentarily here. So while you're copying this down, I'm going to read it to you. And what it says is, if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. That's a whole lot of words. I'm going to explain it with my scissors. I will show you a demonstration. I'm going to demonstrate the Hinge theorem. I'm going to give you a visual. So the converse of the Hinge theorem, basically on this one, they're going to give you the side length, and then you have to decide which angle is bigger. So again, we still need to have the sides congruent before we can even use this theorem. So if two sides of one triangle are congruent to two sides of another, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. So again, two of the sides are going to be congruent, then that third side that you go to compare, the bigger the side, the bigger the angle. And on this slide, I guess you can't see that J that's in here. There's a little J in here. I don't know, the picture got put on top. So there's a J here. All right. Anybody go on? Let's do an example. So here we don't actually have numbers, but we do have a given statement stating that D is the midpoint of AC. What does the midpoint do to a segment? Makes it two congruent parts, right? And it's got the congruency marks here. So we really didn't even need that in the given. We could have said, look at the picture. Now, we still need to have a second side. What other side is congruent, and how do you know that, Isabella?
BD by reflexive.
Good. BD by reflexive. So the two triangles we're talking about are this triangle here, the ABD, compared to the BDC. So what angle 1 is referring to is this side, and angle 2 out to this one. So we know that angle 1 is smaller than angle 2 based on our given. What is that going to tell me about those sides AB and BC? What could I conclude? Tessie?
AB is bigger than BC.
Okay, so that AB is larger than BC based on the Hinge theorem. Does that make sense? Okay, let's try the next example. Anybody still need this slide? All right, let's go to the next one. Again, we're going to complete it with either a less than, a greater than, or an equal to. Again, I need to look for my congruent sides. So I notice I have a 4 here and a 4 here. And then I've got the reflexive side, because the angle we're referencing has to be the included angle. So I have this triangle here, and then I have this one here. Angle 2 is going to look at the 3. Angle 1 is going to look at the 4. Which one is larger, the 3 or the 4? Tessie?
They're equal.
Nope, we can't. The 4 is the congruent. We're looking at this compared to this.
The 4 is larger.
The 4 is larger, making angle 1 the bigger angle. So this 4 that's over here on the side is the congruent side we need for the hinge theorem. And then the other side that's congruent is the reflexive. So remember, by definition, it has to be the included angle. So it's the two sides that make up that angle. So you got to match all those congruencies first. Anybody still need this one? All right, more example, and then we're done. Okay? Now we want to find the value of k. We need to find a range of values for k. Now, when we did it in last night's homework, we had to include the lower end. When you go to answer this in tonight's homework, you can just do the upper end, but I'll show you how you could set up the compound inequality. So first thing we need to do is look for all our congruent sides before we can even apply the hinge theorem or its converse. So
PL and LM.
good, they've got the congruency marks. And then what's the other one? So PL and LM, and we got one more side that we got to show. And Kimberly? And the reflexive. Okay, so now we're going to compare this angle to this one, and we're going to go and look out at the sides. So this third side, which one's larger, 18 or 19? 19. So that tells me that 5K, and let me move it over in the middle a little. That 5K minus 12 is going to be less than 38. Now, if I wanted the lower end, I know it's got to be greater than 0. So if I wanted a whole range, I could put in that it has to be greater than 0. When you go to do the homework, they're only going to look for the left side. But if you want to show the total range, you can. So for this one, what we're going to do is add the 12. Add the 12. 5K is now in the middle, and I get 0, 1, 4, 50, and then divide by 5, and then 12 over 5, K in the middle, and then 10. In the homework, they're only going to expect to see K is less than 10. However, if you give me the lower end also, that's fine. If you made this a decimal, it would be 2.4. On the test, I'm going to look for what I circled.
Did you say k is less than or equal to 9?
No, it has to be, because it could be 9.99. So it could be a decimal. So that's why you're not going to go down to the next whole number. Okay, so you could have angle measures that have a decimal. So this is why we're going to actually solve it with the number that we get. Does that make sense? Okay, because it could be 9.99, which would be less than 10. Okay, so I'm not going to jump it down to just a 9. So what I want to look for on the test is going to be the K is less than 10. Any other questions? So this is your hinge theorem. Again, the two side lengths of the triangle need to be congruent, and then you can compare that third side to figure out which angle is bigger, or if they give you the angle measure, to figure out which third side is longer. Now, when you go to do the homework, I put a note on there that you're not doing the last question. In the practice A tonight, you're only doing 1 through 16. If you happen to go ahead and do the practice B, before you click on the blue link, make sure you read which ones to skip, okay? Because you don't have to do the indirect proof questions. And then on Wednesday, we'll start going through the study guides, tell you what to focus on to study for the test. Oh, one other thing I want to show you is in Canvas, in the module, I've added like an outline that you can fill in, and I'm going to show you how to find that now.